Let's talk about Modigliani and Miller's Proposition 2 with no taxes. You may recognize this formula as the weighted average cost of capital, and if you've spent any time in a finance class, undoubtedly you are familiar with it. Now notice that we have a tax rate over here, and that's normal for the weighted average cost of capital. But what happens in a world without taxes? Well, that thing is 0, and so we're basically just multiplying by 1. So this piece here on the end totally goes away. Now the other thing we need to understand is in this world that the weighted average cost of capital is also equal to, let's call it R naught or R sub 0. How about R naught? R naught is just the required return given the risk of the underlying assets. And we know that the assets of the firm, they have a certain riskiness associated with them, and that requires a certain return. And when we take that required return on the assets, we can look at the required return on the stock and the bonds, and the weighted average of those two should be equal to that required rate of return on the assets, which we would call the firm's costs of capital. And so we're going to do a little rewriting of this now that we have this idea of R naught being equal to the weighted average cost of capital for the firm. Now notice that we have a weight on each one of these. So the weight on the required return on stock is the proportion of the capital that is composed of stock, and that's just the market value of the stock, which would be the number of shares times the share price divided by B plus S. Well, we already know what S is. B is just the number of bonds times the price on the bonds. Note it is not the face value of the bonds unless they just happen to be the same as the price. And another thing we need to note about these weights is that in a weighted average, the weights always add to 1. And so we have S over B plus B over B plus S. We add those together and it gives us S plus B over B plus S. And anybody who spent any time around algebra at all knows that S plus B is the same thing as B plus S. And so basically those things will cancel and become 1. And so we have succeeded in having our weights add to 1. What if, though, we were trying to figure out what is the required return on stock here? Well, we would have to do some rearranging. So here we go. Okay, all I did was swap the sides of the equation, and then I subtracted B over B plus S times R sub B from both sides. And so this one just went away because plus something minus something, if it's the same thing, gives us 0. And we end up with a negative B over B plus S times R sub B with this R sub 0. And so now we want to try to solve this thing for R sub S. So the first thing let's do is multiply both sides by B plus S. Notice that our B plus S here cancels out. And it does over here too, I just didn't show it. And so we are left with S times R sub S is equal to R naught times B plus S minus B times R sub B. Okay, so what I've done is copied that last formula that we looked at, only I've left out the B plus S over B plus S, because after all that cancels and becomes 1. Now I want to try to get R sub S by itself, so I'm going to divide both sides by S. And so I'm left with R sub f is equal to R naught divided by S times B plus S minus B over S times R sub B. Let's do some distributing here and distribute this term over those two, B and S. Now I want you to notice something here. These S's cancel out. And so we are left with R sub S is equal to R naught times B over S plus R sub 0 minus B over S times R sub B. And I can take it one step further. Notice that both of these terms have B over S in front of them. And so I can do the opposite of expanding that. I can now concentrate that. Let's take a look and see what we can do here. R sub S, first thing I'm going to do is work with that term, R sub naught, plus, and I'm going to pull these two terms out, R sub 0 minus R sub B times B over S. And so you may see this formula and wonder where it came from, and now you know. Starting with the same formula as we used on our last board, we can actually now solve this thing for R sub B. So let's do a little rearrangement here and get R sub B on the left-hand side. I'm going to add B times R sub B to both sides and subtract S times R sub S from both sides, and we'll end up with the following. So I haven't done anything magical or strange there. I've just used the basic laws of algebra. And now we have B R sub B on one side and the rest of this on the other. Now we want to get R sub B by itself, and so we are going to divide both sides by B. Okay, now we can do similar to last time. We can distribute this term over these two. Okay, I want you to notice something here. These B's cancel out and just leave R sub 0 by itself. And something else we can notice here is that S sub B is in both of these terms. And so we can rewrite this as R sub B equal to R sub 0 plus R naught minus R sub S times S over B. Okay, so now we have the required return on the debt being equal to the return on the assets plus R sub 0 minus R sub S times S over B. You're probably looking at this and saying, wait a minute, I know R sub B must be less than R sub O because after all, the debt has first claim and then the equity behind it. And so we know that the debt is safer than the overall assets. And that's true, and here's why. Because we know that the required return on the stock is going to be greater than the required return on the overall assets. And because it's riskier than the overall assets if there's any leverage at all. And so this term right here is going to be negative. And so it's going to be R sub B is equal to R sub 0 plus some negative term. So R sub B will be greater than R sub 0 for a levered firm. Now let's talk about the value of the levered firm with taxes. So our annual after-tax cash flow at a firm that is unlevered would be the earnings before interest and taxes multiplied by 1 minus T sub C. Why would that be? Well, if the firm is unlevered, then there won't be any interest to pay. So the only thing we have to pay out of our EBIT would be our taxes. And so that minus T sub C covers our taxes, and so EBIT times 1 minus T sub C would be the annual after-tax cash flow for the unlevered firm. And going on from there, we can figure out what is the value of the unlevered firm. Remember that the price or value of anything is the present value of that thing's expected future cash flows discounted at a rate that is appropriate to the risk of those expected future cash flows. Well, our future cash flow here that goes on forever, because after all, corporations can live forever if nobody messes up, divide by R naught. The required return on the firm will be R naught. Remember, that is the required return on the assets given the risk. And so we can use our perpetuity formula of PV equals C over R to figure out what is this value of the unlevered firm. We have the cash flow here on top, and we have the required return given the risk. And so that's our value of the unlevered firm. But what is the additional value that comes from having debt? Well, the value from debt comes from the tax shield. And the reason we have a tax shield is because interest is tax deductible. In other words, we can subtract it before we calculate our taxes. And so let's start by talking about the taxes that are saved every year due to this tax shield. Well, what is our interest? Our interest would be R sub B times B. That would be our annual interest in dollars. And for every dollar that I pay in interest, I can save my tax rate times that dollar. And so now all I've got to do is multiply by T sub C, and that is my annual tax shield. Now, if we get this tax shield every year, just like we get our EBIT times 1 minus T up here, then we could figure out what is the value of that tax shield using our perpetuity formula, because after all, we'll be getting R sub B times T sub C every year. That is our C in our perpetuity formula. And what is the required return on this thing? Well, it's just R sub B. And so now we can cancel these things out, and that tells us that our tax shield is actually worth the tax rate times the market value of the firm's debt. And so now we can easily write out that the value of the levered firm is just equal to the value of the unlevered firm plus the value of that tax shield. And so it is equal to EBIT times 1 minus T sub C divided by R naught plus T sub C B. As we just said, the value of the levered firm is equal to the value of the unlevered firm plus the tax rate times the market value of the debt. But we also know that the value of the levered firm is equal to the market value of the stock plus the market value of the bonds. After all, assets equal debt plus equity. And so the total value of this thing has to be the debt plus the equity. Now we can do a little bit of rearranging here and come up with the following. The value of the unlevered firm is equal to S plus B minus T sub C times B. And I can extract this B from both of these terms and get S plus B times 1 minus T sub C. And so we can say that the value of the unlevered firm is equal to S plus B times 1 minus T sub C. Now let's talk about the cash that comes from this every year for the shareholders and the bondholders and compare that to the returns on the unlevered firm and that tax shield. And so what I'm going to do is I'm going to say that the shareholders receive S times R sub S, and the bondholders receive B times R sub B. So far, so good. Now, where does that money come from? It comes from the unlevered firm value and the tax shield. And so that value of the unlevered firm is returning R naught. And then we have our tax shield, which is previously we've said is B times T sub C, and that is, the cost of it is R sub B. And so what we're really looking at here is these are the cash flows to the investors, and this is where that money is coming from. And we can do a little bit of substitution here since we have the value of the unlevered firm as this amount right here. Okay, now that we have all of this written out, we can actually now solve for R sub S. So let's go ahead and do that. Well, the first thing I want to do is subtract B times R sub B from both sides. And so now I have S times R sub S by itself. And what can I do beyond this? Well, I can divide everything there by S. But let's do a little distribution first because this is getting kind of messy. And so that's what I'm going to do next is a little distribution. S times R sub S is equal to S times R naught plus B times 1 minus T sub C times R naught. So I've just distributed that R naught term. Plus B sub T sub C R sub B minus B R sub B. Okay, I think we can actually clean this up even a little more. So let's distribute this one even further. Okay, it looks like I've ran out of room, so we're going to have to go to the next screen to find out how the story ends. Okay, so I've simply copied what I had previously at the bottom. It's now at the top, and we have one more step left until we can figure out what is the required return on the equity of a levered firm. And so let's divide everything by S. Okay, so now we have everything divided by S. And we can start to simplify some things. First of all, S here cancels out. And so what we are left with would be the required return on the stock being equal to the required return on the assets. And then we can do some extraction here where we pull out the B over S. So let's go ahead and do that. Plus B over S. And that's going to give us R sub 0 minus R sub 0 TC plus R sub B TC minus R sub B. Okay, what can we do next? Well, it looks like we have R sub 0 times 1 minus TC right here. So let's go ahead and collect that up. And then it looks like we could subtract have negative R sub B here and extract that and end up with 1 minus TC as well. Okay, now we can do another extraction here. We could say R sub S is equal to R sub 0 plus B over S times 1 minus T sub C times R naught minus R sub B. And there we have the simplest form of the required return on the stock for the levered firm. It's just the required return on the assets plus the proportion of the capital structure that is debt multiplied by 1 minus T sub C multiplied by R naught minus R sub B. And remember that R naught minus R sub B will always be a positive number because the assets of the firm are riskier than the debt of the firm because the debt gets paid before the equity of the firm. And so this is a safer set of cash flows than it would be for a just plain unlevered firm, which would be the risk of the assets with R sub 0 return.